And now we continue with our spotlight presentations. Dr. Virginia Burkett is Chief Scientist for Climate and Land Use Change at the United States Geological Survey. She is widely considered one of the world's top experts in wetlands, climate change, and low-lying coastal systems. She has published over 100 journal articles, book chapters, and reports that focus on these topics. She is extensively quoted by the media as well as by scholars and researchers around the world. Her work with the United Nations as the lead author of the United Nations Intergovernmental Panel on Climate Change, third, fourth, and fifth assessment reports, and the IPCC technical paper on water are just two examples of her prolific recognition as a champion for the Earth. And because of this notoriety, she has been appointed to over 70 commissions, committees, science panels, and boards during her career. She currently represents the U.S. Department of the Interior on the National Academy's Climate Security Roundtable. She co-chairs the International Activities Working Group of the U.S. Group on Earth Observations and is a U.S. delegate to the International GEO, which consists of representatives from 115 countries. It is indeed an honor for AGS to welcome Dr. Virginia Burkett this afternoon.
Thank you so much to the AGS organizers and to Columbia University for inviting me to speak today about managing the global commons. I had several choices of topics, and this one was the one that I found the most intriguing. I have a lot to cover in 20 minutes, so let's get started with some definitions and some historical context. You've probably heard, even you students, about the tragedy of the commons or the tragedy of the global commons in reference to the degradation of areas or resources that are not subject to the jurisdiction of a particular nation. The phrase in general refers to international areas shared by states or the international community as a whole. The concept of the global commons refers to areas, natural resources, and systems that are not subject to the sovereign jurisdiction, as I mentioned, of a single state. The concept global commons resembles the concept of the common goods in the 16th century and before. An example, Hugo Grotius, considered the father of the law of the sea, relied on his seminal Mare Liberum, which means freedom of the seas, which he wrote in 1609 to defend Dutch claims to the free seas and to oppose claims on sovereignty over the waters of the Atlantic and the Indian Ocean by Portugal and Spain. Grotius argued, 1609, quote, "That which cannot be occupied or which has never been occupied cannot be the property of anyone, because all property has risen from occupation." That's kind of a starting point for where we have come to today. So the initial concerns for the ocean commons were not focused on the prevention of degradation or damage, and certainly not over-exploitation, which we're dealing with today. It was all about access and control at the time. The three other spheres of the commons generally referred to in the historical literature are the moon and outer space, polar regions, and the atmosphere. These geographies and physical domains all have one thing in common. They are not, for the most part, habitable. Exploration of outer space began with the Russian Sputnik mission in 1957, followed by the first human in space, also Russian, in 1961. That same year, President John F. Kennedy called on the Congress to send a man to the moon and return him safely to the Earth. That same era, 1967, the Outer Space Treaty was declared that outer space, including the moon and other celestial bodies, shall be the province of mankind. And then there was a moon-specific agreement in 1979 that cast the more modern terminology in the common heritage of mankind. The Earth's polar regions have very different geographies, as you're probably aware. Antarctica is a continent with a vast landmass, part of which is claimed by bordering states, whereas the Arctic region consists of a huge mass of ice-covered sea surrounded by continents. Antarctica has been the subject of many treaties, with the 1959 Antarctic Treaty at the core. In contrast, the Arctic region lacks a specialized international governance structure, But there have been some exceptions, like the 1973 Agreement on the Conservation of Polar Bears, for example. And since 1996, the Arctic Council has been in place as a high-level forum. EEZs, shown here, are one of the outcomes, the decision to manage or allocate EEZs in the debate about the ocean's commons, and 300 years of that debate at least. The United States participated in the original negotiation that led to the United Nations Convention on the Law of the Sea, which was finalized in 1982, but President Ronald Reagan announced that the United States would not sign that treaty due to its provisions on deep seabed mining. The U.S. is still not a signatory, but we continue to recognize the claims of foreign nations for their EEZs. And this one on the left here, this is one of my partner bureaus in the Department of Interior, the Bureau of Ocean and Energy Management. And so these are the Outer Continental Shelf EEZ area that has been claimed since 1983 and in which the U.S. Is considered manager and owner of that area. And then on the upper right is the EEZ. Do you know that the original 3-mile limit is called the cannon shot? I live in Louisiana. I always wondered why we had a 3-mile limit. That's how far a cannon could go. So then with these treaties, it's extended out 200 miles. And when there are neighboring countries, they negotiate where the line will be. So that is fairly well accepted. And for the purpose of exploring, exploiting, conserving, and managing natural resources, whether living or non-living, of the seabed and its adjacent super-adjacent waters. Global Commons now, the term, refers more to a broader set of geographies and resources. Natural resources, for example, seabed minerals. This is some of our staff working on a NASA vessel taking photos of manganese nodules on the Blake Plateau off the coast of South Carolina and Georgia. So resource here implies either realized or potential scarcity, which results from a situation of crowding or competition, and some of the examples include cobalt, nickel, and manganese. Living ocean resources. And even more recently, since 1936, when the first oil field was developed off the coast of Louisiana, the Creole field, there have been development of deep seabed energy sources. This is the Shell Appomattox platform, which is located in 7,400 feet of water, 80 miles off the Mississippi Delta to the east. And it can hold 180 people, 24 hours a day, 7 days a week. And it is can handle 175,000 barrels of oil a day. And the crew, as I said, averages about 180 people. Indeed, habitable and occupied. So living resources, in addition to the seabed minerals, are also something that has evolved due to scarcity and exploitation. Fish, for example, we allocate marine fish to maximize sustainable yield as a common way that conflict is handled in the fisheries sector. When I was Secretary of Wildlife and Fisheries for the state of Louisiana, we were overfishing redfish and speckled trout and red snapper in the deep Gulf. And so what we did is, through the Gulf of States Marine Fisheries Commission, we sorted out through the data what the sustainable yield would be, and then we had an allocation for the commercial fishermen and the Recreational Commission, and all 5 Gulf states adopted it. So similarly, for waterfowl, another scarce resource if they're over-harvested. So there's an international partnership for these living resources in the commons that is between the United States and Canada beginning in 1986, and in 1994, Mexico signed on to this agreement that uses data and science as a basis for managing waterfowl populations. So in addition to the natural resources being added to this framework of the global commons, we now have a much greater understanding of the importance of Earth systems and their processes and their interactions, shown here, especially now we understand our impacts collectively on the climate cycle. So the term systems communicates both the complexity of a functioning set of components and the flow of energy between them and powering them, and a process for internal regulation of their functioning and feedback. So any actions that restrict or diminish these systems can lead to conflict between states, nations, and sectors. Our growing understanding of these interconnected systems, coupled with an unequivocal signature of increasing global temperature, has heightened concerns about human impacts on the atmosphere. So we had the ocean conflicts fairly well resolved with the Law of the Sea Treaty, and some of the provisions are just shown here. And then we have other agreements, like the one I mentioned on the waterfowl, that help protect other domains of the global commons. I've mentioned several of these. Let me look briefly at the Montreal Protocol. So the Montreal Protocol is considered a huge success because it was unanimously adopted by governments around the world. Why? Because science, data, public acceptance, and trust of findings and assessments brought about this unanimous consent. A fund was established to offset costs to developing countries. Remind you a little bit of the Paris Agreement and the UNFCCC approach, because it worked for the substances that would disturb the ozone layer. A big part of the Montreal Protocol's success is that it wasn't a one-on-one or one-and-done strategy back in the 1980s. Rather, the treaty has been amended over and over, each time making the agreement better for the environment based upon the most recent data and scientific research. And if you look at the United Nations Framework Convention on Climate Change in 1994, that's kind of how this framework has operated, continuing to advance based upon the science, the assessment reports by the UN and the individual nations, and the data, the geospatial data that underpins all of these assessments. So in 1994, it was adopted, has near universal membership. 198 countries ratified the convention. They're parties to the convention that calls for preventing dangerous human interference in the climate system, which is the ultimate goal or aim of the UNFCCC. It puts the onus on developing countries. And the Montreal Protocol, there was a developing country fund to help countries that were in a developing status and get the resources they need to adopt the aspects of the Montreal Protocol. And the same is being attempted in Azerbaijan today. So I'm going to run through the rest of these very quickly. The Anthropocene has brought new challenges to the global commons. The Anthropocene was proposed as a new epoch, geologic epoch, but just earlier this year, it was rejected by the International Commission on Stratigraphy because it did not, they say the time frame was too short. The geologic stratigraphy signal was there. And will it continue, or should it be considered an era? Even though it was not ratified by this international geophysical organization, it still has benefit because it has enabled us to understand that the degradation and loss of systems caused by human activity is affecting the sustainability of life on planet Earth. The Earth's atmosphere, the last thing I'm going to talk about is the atmosphere, only about 80 miles thick, 60 miles thick, diameter being 8,000 miles. So approximately 75% of the total mass of the atmosphere is only in the 5 to 9 miles above where we stand today. The ice core record of the past 420,000 years shows these natural fluctuations due to orbital eccentricity. And the upper blue line is the CO2 level, the lower red line is the temperature. In 2023, the average was 419 parts per million volume. which is about doubled what it was before industrialization. Atmospheric carbon is now highest as it's been in 2 million years at least, and the sources of the change or the emissions to the atmosphere are shown here. Fossil fuels being the primary change, and the others forestry and land use change, the loss of carbon stored. Human activities are unequivocally the driver of this change, no question. Here in one of the NCAs, we charted, we factor, people say, well, what about volcanic activity and solar flares? And that is all factored into these assessments. Global temperature is rising, but there's a lot of regional differences. And atmosphere is not only affecting the temperature of the oceans, but also polar regions and the biosphere are responding. And this just shows the regression through the ocean and land temperature anomalies since 1895. And the ice sheets are declining. Greenland ice sheets shown there from NOAA in 2023, and the decline of sea ice shown here in the right in our most recent National Climate Assessment. Projected changes, instead of looking at years, you can look at what the temperature would be like at 1.5 degrees C. We're already at 1.1 degree plus over the pre-industrial era. And, I'm sorry, the wrong one. And at 4 degrees C, you can see the temperature change, which affects the hydrologic cycle and precipitation and soil moisture. Tremendous changes ahead on the trajectory that we're currently headed on, according to the IPCC. The red line here is a line through the historical observed changes, and then on the right side, you can see, let's see if I can get this, there you go. You can see that the longer it takes for emissions to be curbed, the less likely it will be to reach this 1.5 degrees C line across on the graphic from left to right there. So the IPCC, in a special report on limiting warming to 1.5 degrees C, basically looks at hundreds of different scenarios into the future. And again, this shows that the longer society waits to reduce emissions to the atmosphere, the deeper the technologies and the deeper the emission cuts will need to be into the future. They conclude that the only way to keep the temperature increase to 1.5 degrees C and to achieve sustainable development is decarbonization of the economy, carbon dioxide removal and sequestration, and a mix of greenhouse gas emission mitigation and adaptation strategies. Avoiding the global temperature increase that you saw on some of those prior graphs of 4 degrees or so will require emissions reduction and rapid advancement in technology. I love what was said earlier today, so much emphasis on the evolving technologies and how important they are. This report led by Stephen Pacala at Princeton about negative emission technologies, basically running emissions in reverse, concludes that the technologies that are available, and they list 7 different areas of technology that could be developed, could have the same effect as removing atmospheric CO2 in the same way, simultaneously preventing emissions of an equal amount of CO2. So the options for managing the global commons shown here differ from other types of, well, first let me say, this is a historical view, kind of, 1997, cited often, Hollick and Cooper, the 3 different ways that the global commons can be managed. Laissez-faire, which is an interesting option, literally means to allow to do in French, with the idea being let people do as they choose. Well, laissez-faire has led to what the UN has now dubbed the triple planetary crisis: climate change, biodiversity loss, and pollution. These 3 interconnected environmental crises are causing a lot of concern in the international community, And in July of this year, UNEP, the United Nations Environment Program, identified 8 critical shifts that are accelerating this triple planetary crisis that is caused by letting nations do as they please. The other one is that they mentioned in the 1997 is this management via partition, like the fisheries example that I gave and the wildlife example. And then finally, this joint management by more than one nation. And that's like the Montreal Protocol and what the governments are trying to do through the UNFCCC. So policymaking today, instead of focusing on those sorts of approaches, it focuses on reducing risk while allowing sustainable development. The Sustainable Development Goals, the 17 that I showed there, including reducing poverty or ending poverty and dealing with climate change, those are what we refer to today as the approaches for managing the planetary commons. The theme of cooperation in conflict really comes out when we think about mitigation and adaptation, which are the 2 major options for managing risk associated with climate. So reducing greenhouse gas emissions and having data to support decisions about the future needs for adaptation and mitigation all depend upon sound science from the bottom up and budgets that are developed and monitored from the top down with technologies and a lot of geospatial data that goes into these decisions, including the assessment and the global stocktake that occurs every 5 years. So this is a chart that we came up with for the fourth IPCC report that just basically shows Rockström's planetary boundaries. You're probably familiar with those, where you've got the biophysical stressors on human populations and ecosystems, and the resilient space being squeezed with the social stressors and the external forcing. And the resilient space, whether you get to a planet with a high resilience and a low risk future, depend upon the decisions that are made today. The ones that are being made in Azerbaijan, for example, this week. The decision points here, I like this because it shows that you can make decisions that might get you off track towards that pathway to low resilience, and then pick back up and get to a higher resilience sort of pathway, but you never can get quite as easily back up to the very top. I'll leave you with this proposed categories of the planetary commons that was published in the Proceedings of the National Academy of Sciences by Johan Rockström and his colleagues earlier this year. And you can compare that to what we started with and the evolution of change. So one of the things that was said today by the author of the beautiful book, and I love the fireside chat, Dr. Arnold, that he shared the hope of technology and education. And I share that hope. We are not helpless. And I also share, and I want to add a third thing there, and that is that nations have an earned trust in data and in science to underpin decisions, because I think that's at the core of the future of our planet. Thank you.
Thank you, Dr. Burkett. It's an honor to have you with us today.